Hello and welcome to T3 Day 6 of Honors Precalculus. Today we're going to be talking about solving quadratic systems. So this means more than one equation, so two in this case, x and y, and at least one of the terms is going to have x, one of the lines is going to have x and or y squared in it. So how do we go about solving this? To solve an equation, it means to find a set of values, coordinates x and y, such that when you plug them into both, they're both true at the same time. So we're going to use substitution on this one. It's kind of nice. And the way that's going to work is in the second equation, we're going to isolate x and get x is equal to 2 plus 3y. We're then going to take 2 plus 3y and substitute that in for x up here, leaving us with, and I'll rearrange it like this, 3y plus 2 squared plus 4y squared is equal to 29. And I'll try to make my 4's actually look like 4's. So 4y squared, y squared. And now what I'm going to do is multiply this out. I'm going to multiply this out. So when you do this out, you end up with 9y squared plus 12y plus 4 plus 4y squared is equal to 29. And this is just a quadratic. When you combine all the terms and make it equal 0, which is really what we're aiming to do because we like it when things equal 0, you get 13y plus 12y minus 25, and you hope that this is nicely factorable. It actually is, and 13 is a bigger number, but it is prime. And when you factor this out, it's going to be 13y and then 9, so just y. And when you play around with this, you end up with 25 here, and you end up with minus 1 here. It does work. It's pretty cool. But keep track of what you test when you factor. So that means that 13y plus 25 is equal to 0, or y minus 1 is equal to 0. So y is either equal to negative 25 over 13, or y is equal to 1. Now what you need to do is also find the x coordinate. So we know that x is equal to 2 plus 3y. So x is going to be equal to, in this case, when we evaluated it, y is equal to negative 25 over 13. It's going to be equal to, remember, 2 plus 3y. So that's 2 plus 3 times negative 25 over 13. And this one over here, x is going to be, when y is 1, is going to be just 1, because it's still just 1 no matter what. So the point over here is going to be 1 comma 1, and then when you do out this fraction, you end up with negative 49 over 13. So the answer is going to be negative 49 over 13, comma, negative 25 over 13. So there are two, oh, excuse me, and it's not 1, 1 here. Pause. It's equal to 3 times 2 plus 3y, sorry, 2 plus 3y, and y is 1. That was my mistake. So it's just a 1 right here. So then that's going to be, x is going to be equal to 5 right there. That's equal to 5. So you have two answers here, here and here. The key on this one is to not give up on the factoring right here. Just be really careful. Keep track of what you've tested. Now in the second one, we're going to do the same thing. We're going to let x equal y plus 2, and then we're going to take this and plug it in up here. So we end up with, after we plug it in, we end up with y plus 2 squared minus 3y squared is equal to 8. And when you multiply this out, you end up with y squared plus 4y plus 4 minus 3y squared equals 8. Similar to the other side, we want to put everything on one side and combine like terms. So we end up with negative 2y squared, that's the two terms on the left right there, plus 4y minus 4 is equal to 0. We're going to factor out a negative 2 just to make this easier to factor. So it's minus 2y plus 2 is equal to 0. This right here is not nicely factorable. Alexa, stop. So when you use the quadratic formula, you're going to get y is equal to plus negative b. So it's going to be, we're doing it on this right here. Y is equal to, so 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 2. This is the quadratic formula, all over 2a, which is 2 times 1. And when you do this out, you end up with 2 plus or minus the square root of 4 minus 8 is negative 4 over 2. So what that means is you have two imaginary roots. So you could say that those are the two solutions, but if we're staying in real numbers, you would say that there's no solutions. There's no real solutions on this one, no real solutions. So we did those other two by substitution. Now you can do it another way. So for example, sometimes you get a really nice one like this, and it's, quote, nice because you end up with two terms here that are opposites of one another. So what you can do here is called linear combinations, but you can just add these together. So this added together is 6x squared, but when you add these together, the next two right there, you end up with 0y squared. So this is just equal to 24. 25 minus 1, so x squared is equal to 4. So x is equal to plus or minus 2. The key thing here is finding the other potential answers. So the way you do that is you pick which one you're going to plug it into. And you can do either, but let's plug it in right. Let's go to the top one. And when x is 2, what happens? So you have 4 times 2 squared plus y squared is equal to 25. So that means that 4 times 4 is 16. 16 plus y squared is equal to 25. So you end up with y squared is equal to 9. So y is equal to plus or minus 3. So the key thing here is when x is equal to 2, you get 2 answers. So the 2 answers here are 2 and 3 and 2 and negative 3. But then you also have to do x equals negative 2 over here, the other one right there. And when you do that, you get 4 negative 2 squared plus y squared is equal to 25, which results in the same thing. Y is equal to, because negative 2 times negative 2 is 4, plus or minus 3. So with this one right here, you end up with 2 more answers, similar but not the same, negative 2, 3, and negative 2, negative 3. So in this case, there's 4 answers here. There's 4 of them, which is pretty cool. On this one, there's a new structure, which is this square root here. The first thing we're going to do is we're just going to get rid of that by squaring both sides. So when we do that, you're going to end up with x squared plus y squared is equal to 1 minus y. So we're just going to square both sides here. We're squaring both sides, which is totally legal. When you do this, I need you to remember, though, you need to check your answers. Check answers. You can generate false answers when you do this. So when you end up with this, you end up with that one, and then you end up with this same equation right here, like this. So what I'm going to do now is eventually substitute, and there's a square here. I'm going to square this out first. So this is the first line, equals 1 minus 2y plus y squared. And what's nice here is the y squareds cancel, and you're left with x squared is equal to 1 minus 2y. So then what you can now do is substitute. So this one right here tells us that 2y is equal to negative 1 minus x. So 2y is equal to negative, oh, there's the 2y right there. So what we can actually do here is take this and plug it in right there, because that's 2y. It's a little bit shorter that way. So x squared is equal to 1 minus 2y is negative 1 minus x, like this. So what you end up with is x squared is equal to 2 plus x, like this. So then you put everything on one side, you get x squared minus x minus 2 is equal to 0. So you have x plus 1 times x minus 2 is equal to 0. So x is equal to negative 1 or 2. So let's solve for the y values now. Let's solve for the y values. So we know that 2y is equal to negative 1 minus x. So what we can do here is 2y. So when x is equal to negative 1, 2y is equal to negative 1 minus negative 1, like this. So 2y is equal to 0. So y is equal to 0. So our first answer is negative 1, 0. There's one of them. But then x could also be 2. So 2y is equal to negative 1 minus 2. So 2y is equal to negative 3. So y is equal to negative 3 over 2. So the other answer is 2 comma negative 3 over 2. But at the beginning there, what I said was we need to check these answers. You check these answers by plugging them in to one of them. Let's go to the first one here. So for example, we know that this has to be true. Square root of x squared plus y squared has to be equal to 1 minus y. So let's try both of these right here. So the first one that we need to check is that first one, negative 1, 0. Does this work? Negative 1, 0. Does it work? So let's check it. So it's going to be the square root of negative 1 squared plus 0 squared. Well, that's going to be the square root of 1, which is 1. And then on the other side, 1 minus 0 is 1. So it does check. So this one does work. What about the second one? You have the second point is 2 comma negative 3 over 2. You plug that in. So you get the square root of 2 squared plus negative 3 over 2 squared, which is going to be the square root of 4 plus 9 over 4. And does that equal the same thing on the other side? Let's add these together here. So this is equal to 16 over 4 plus 9 over 4, which is equal to 25 over 4 square rooted, which is equal to 5 over 2. So that's the left-hand side. What about 1 minus y? Well, y is equal to negative 3 over 2. 1 minus negative 3 over 2, right there, is going to be 2 plus 3 over 2, which is indeed 5 over 2. So these both check. So they both work. They both work. The key thing to take away from this one is when you square, whenever you do that, you have to absolutely make sure you check your answer. So in this question, we're finding the intersection of a circle of radius 4 with that center and a hyperbola with another center, and it's got a transverse axis length and a conjugate axis length. So when you're doing this, what you need to do is write the two equations. The two equations are going to be x minus 2 squared plus y plus 3 squared is equal to 16. And so you have the circle and the hyperbola right there. So the one thing you can notice is that you can multiply this by 4.5 and you end up with x minus 2 squared minus y plus 3 squared is equal to 4.5. So we're trying to find out where this and this intersect one another. So if you look at these, you might be tempted to multiply them out, but if you notice that you have two things that are the same in both, but one's opposite. So you have the positive one and then you have the negative one. So if you add these together, if you add these two things, you add this and this, you end up with 2 times x minus 2 squared, and then the y's cancel right there, leaving you with 2 times that equals 20.5. That's 16 plus 4.5. And then when you divide by 2 and square root it and add, you end up with x is equal to 2 plus or minus the square root of 10.25. So you end up with that right there. So there's two answers there. So what you need to do after you do that is you have to take this decimal right here. There's two of them. 2 plus the square root of 10.25. You need to find the y value. And then there's another one, which is 2 minus the square root of 10.25 and find the y value. So what you need to do is you need to plug in both of these values into one of the original equations. I would go with the top one here. That's fine. You plug that in for the x value and solve for the y value. And I'll leave it to you to figure out that you actually end up with 4 answers. So you end up with 4 because when you plug in 2 plus and then 2 minus, you end up with 2 answers each. You end up with these 4 answers. So I'll leave it to you to get from there to there, but you take these two numbers and you plug them into the top equation and then you solve for y. So you get 2 for each. This is the same 2 for each, so you get 4 answers. 4 answers.